Software Development Process Models, written and presented by me, John Leguay. Here's the legal stuff. Once again, I've used this website as reference, and the link will be available on eCampus. The waterfall model. This is probably the traditional top-down engineering model with its familiar Gantt charts. This is essentially what we do when we use MS Project. Each phase must be completed before the next, although if enough resources are available, parallel processing is possible. This model is still used for small projects with limited uncertainty. A critical path can be found to determine limiting factors. A review at the end of each phase can result in the abandonment of the project. The customer is only involved in the specification and after deployment. The maintenance phase can be extended since it often involves changing the code to give the customer what he actually wanted in the first place. The waterfall model is suited to short, simple, well-defined projects. It is very well known and widely taught. It does not deal with changes such as changing technology, scope drift, or ambiguity. On long projects, it can go seriously off the rails, with the project manager devoting all his time to updating an increasingly inaccurate project plan. I'll give you a few moments to read the pros and cons. The incremental model. This is like multiple waterfalls. The whole project's divided into builds. Each cycle is divided into smaller, more manageable modules. Top-down design. Working software is produced in the first module, early in the project phase. The incremental model is best suited to projects where resources may be distributed. Speed is important. An early working model is available. Risks are mitigated by modularization. The interconnections between the builds must be well defined to avoid disaster. The V model, verification and validation. This is the waterfall model with parallel testing. The testing is planned in parallel with the stages of development. High-level design concerns system architecture. Low-level design concerns system components. The V model is best suited to small to medium projects where resources are available and everything is understood. There will be no surprises. It is a very rigid, inflexible system, and as such is often suited to the military and military projects. The iterative model. This is a learning model. It starts with an incomplete specification. Produce part of the software, review it, identify further requirements, produce new version, and we go round and round and round. And hopefully we end up producing what the customer wants, even though at the beginning the customer didn't know what he wanted. The iterative model is best suited to big projects where the final outcome is well defined, but the details aren't. The model evolves. The RAD model, Rapid Application Development. The project is developed in multiple mini projects, subcontracted out, and later assembled into a whole. Multiple teams develop the mini projects in top-down environments. This system is well suited to object-oriented design. Business modeling is used. This is used to define data objects needs for business. Process modeling. The data is used to create information and information flow. It creates what's called CRUD. Create, read, update, delete. And that's used to keep this stuff up to date. Application generation. We convert the process models into actual code. And then testing and turnover. We're testing the components. The RAD model delivers a product very quickly. It's very dependent on good teams, and you need to have a really good integrator to put it all together. The Agile model. This is a type of incremental model. This and the waterfall model are probably the most popular models. Software is developed in rapid incremental cycles. This is how the Agile model should work. Stage 1. You develop a framework. One or more sub-projects is developed. Stage 2. Further development with more sub-projects developed. Stage 3. The project is complete. This is a slightly cynical view of how the Agile model actually works out in reality. All the little sub-things are developed, but they never quite get put together in the right order. The Agile model should produce rapid results with great flexibility. If it's not well managed, it can go horribly, horribly wrong. The risk-based spiral model. This is essentially similar to the incremental model, but with more emphasis on risk analysis. The spiral model is suited to mid to big projects where high risks are present. The prototype model. We knock up a quick prototype, give it to the customer, and ask him what he thinks. We take the feedback from the customer, and we use that to develop a final product. The prototype model is useful when there is need for lots of customer interaction. The implementation and repair methodology may encourage deployment of very poor software. Essentially, it may be a whole collection of band-aids. And that's it for models.